Alright guys, I had a quick question about a polynomial equation. Let's say you had an equation that looks something like this. Say 3x to the fourth equals 1029x. Okay? So, again, this is called a polynomial equation. Now the thing is, you're going to solve this just like you would, or maybe not just like, you're going to attack this like you would a lot of other types of equations. You're going to try to factor it, maybe use the zero product property. And then you might reduce this to a quadratic and do things like a quadratic formula. I mean, among other things. You know, we combine all those techniques you've been talking about to try to figure this out. Okay? So let's see here. So the first thing I would do with most any equation I am dealing with is try to divide out any common coefficients. Now, not x values right now. We don't want to divide both sides by x. We want, because we'll lose a solution at that point. But if we can say divide both sides by 3, then that might help us out a little bit. So let's see here. You know, of course, the left-hand side is divisible by 3. But what about the right-hand side? 1029 divided by 3 is 343. So if we said divide by 3 and divide by 3, we could rewrite this as x to the fourth equals 343x. Okay? And now, as with most equation solving, not all, but with most, you want to get everything on one side. That is, I would like to keep this positive, so I'm going to subtract 343x from both sides. And we can rewrite this as x to the fourth minus 343x equals 0. Okay? And now is the point where we probably want to factor. What do these have in common? Well, they both have an x in common. So factor an x out, and what are we left with? X to the third power minus 343 equals 0. Okay? Now, we have factored as much as we can as far as common terms are concerned, but this should ring a bell right here. Okay? We have a cubed term. Anytime you see a cubed term, and you might be able to use the difference of two cubes in this case, or if it was a plus there, maybe the sum of two cubes. So remember, the difference of two cubes, it says this. If you have x cubed minus, let's see, y cubed, that factors as x minus y times x squared plus xy plus y squared. Okay? So we can factor this, you know, that x stays there. This can factor as x minus y. Oh, you know what? I haven't written this in the sum of two cubes yet. So we could say that this is x cubed minus, now what's the cube root of 343? Let's see. What times itself 3 times is 343? 7 times 7 times 7, I believe. Yeah, that's 7 cubed. So this is 7 cubed. So we can rewrite this as x. Oh, sorry about that. We can write this as x minus 7 times x squared plus 7x plus 49. Okay? And that's just something you need to have memorized. It's the difference of two cubes. There's also a formula for the sum of two cubes. But here we have difference because it's a negative sign. Okay, so we have x, let's just substitute in, x minus 7 times x squared plus 7x plus 49 equals 0. Okay, now we can now employ the zero product property. The zero product property says if you have one or more numbers, real numbers that is, and these are all, and these are both real numbers. It turns out this is not going to be real, but if you have these factors like this, you have several numbers multiplied together equals 0, then one or more of those numbers must be 0. So what we're going to do here is set each of these factors individually equal to 0. So we're going to set x, this first factor, set x equal to 0, set x minus 7 equal to 0, and set x squared plus 7x plus 49 equal to 0. We're going to solve each of those individually. So here we go. So we can say by the zero product property. Now sometimes that's called the zero factor theorem. There's lots of names for it. We can say either x equals 0, x minus 7 equals 0, or x squared plus 7x plus 49 equals 0. Now, two of these are very easy to solve. In fact, that one's already solved for us. There is one of our solutions, x equals 0. This next one is really easy to solve. It's just a linear factor. All we have to do is add 7 to both sides, and x equals 7. Okay? So there are two of our solutions. Now, depending on what your directions say, we might be done. If the directions said find all real solutions, we would be done. Because it turns out the solutions we're going to get here are going to be non-real. Now we need to go ahead and do that because lots of times the directions will say find all solutions. In that case, that would include imaginary or complex solutions. So let's go ahead and solve this last one. Now, there would really be no way, well, there is ways to tell, but if you're not really adept at looking at such things, you're not going to be able to tell that the only resulting solutions there are imaginary. So you just need to go ahead and always try to solve each of the factors. Now, let's go over here and try to solve x squared plus 7x plus 49 equals 0. Oops, let's fix that. Now, you probably want to maybe probably use the quadratic formula. In fact, that's what I'll do here. It's good practice. So I can say that x equals, well, let's go ahead and label everything. We can say that a equals 1, b equals 7, and c equals 49. So let's see here. We have x equals the opposite of b, so negative 7 plus or minus the square root of b squared, so that's 49, minus 4 times a, which is 1, times c, which is 49, all over 2a, or 2 times 1. So let's do a little bit of simplification here. Negative 7 plus or minus, let's see, 49 minus 4 times 49 is negative 147. Okay, so negative 147 over 2. Okay, well, let's see if 147 simplifies or not. Negative 7 plus or minus, okay, let's think about this. If we can simplify that square root, well, first of all, we're going to get an I in there, but we might be able to simplify it a little more than that. Let's see, 147 is not divisible by 2. Is it divisible by 3? Yes, it's divisible by 3. Is it divisible by, oh, you know what? 3 times 49 is 147. So let's see, just off to the side, we can say this. We can say that, here, I'll go over here. we can say that the square root of negative 147, well, we can do a couple things here. We can say that is equal to 49 times 3. Oh, let me fix that. 49 times 3 times negative 1, which we can say that's the square root of 49 using the properties of radicals times the square root of 3 times the square root of negative 1 equals 7 square roots of 3, and that's I. So the square root of negative 1 is I. So going back over here, we can substitute and say that is 7 square roots of 3 times I. Now that I is not under the square root sign, over 2. Now last thing, these are the solutions to this portion right here. We want to make sure to write them in a plus bi form generally. So we can say the solutions are negative 7 over 2 plus or minus 7 over 2, well, 7 square roots of 3 over 2i. So one solution is negative 7 over 2 plus 7 square roots of 3 over 2i. The other solution is negative 7 over 2 minus 7 square roots of 2i. Okay, so there are our solutions. Now, how many solutions are there? There's 1, there's 2, and there's 3, 4. That's what we're looking for. There's going to be 4 solutions to a 4th degree polynomial equation. Okay, that's something we'll talk about in the future. So this one's pretty tough here. Just to review, we started off with this equation up here. 3x to the 4th equals 1029x. We divided both sides by 3. We divided by whatever the largest non-zero common coefficient they had. We didn't divide both sides by x because we'll lose the solution that way. We then set it equal to 0. We factored, first of all by factoring common terms, second of all by factoring differences to cubes. We then used the zero product property to find the first 2 easy solutions. Then we then used the quadratic formula to find the last 2 harder ones. So we have 2 real solutions, 2 imaginary. Sometimes you will only be looking for the real solutions. But if not specified, we're looking for all solutions, which would include 0, 7, and these 2 imaginary, or complex solutions down here. So, hope it's been helpful. If you need more help, just let me know.